Hello everyone, my name is Hope Matebula. I'm doing BIT 1 at Rosebank College in the year of 2019, and this module is Network Architecture. In this presentation, you will learn and gain the knowledge and understanding of the OSI model, TCP, OIP, and Internet model. Let's go through it. Videos has become one of the easiest ways to gain and keep attention from the audience. In this tutorial presentation, you will gain the knowledge and understanding of the OSI model, TCP or IP, and Internet model. Activity 1. The purpose of the OSI reference model. The purpose of the OSI reference model is to show the way to developers and salespersons to the software programs and digital communication products they create can interact and to facilitate an visible framework that describes the functions of a telecommunication or a networking system. The OSI model has pros and cons, which are pros. It has the flexibility to adapt to many protocols. Number two, it is more secure than all services being bundled in one layer. And the cons. First, not just any particular protocol is defined, and lastly, layers cannot work in parallel. The different functions of the layers of the OSI model. 1. Physical layer. Layer number 1. This is the lowest layer in the OSI model. It contains information in the form of bits, and it is the one responsible for the physical connection between the devices. This layer, when it gets the signal, it converts it into zeros and ones, then send them to the data link layer, which will put the frame back together. The functions of the physical layer. Bit rate control. This is the transmission rate, the number of bits per cent per second. 2. Bit synchronization. The layer provides this by providing a clock. That clock dominates both the sender and the receiver. 3. Physical topologies. The layer specifies the way in which the different devices are shared. 4. Transmission mode. The layer determines the way in which data flows between two connected devices. The transmission modes are simplex, half duplex, and full duplex. Modem, cables, and hub are physical layer devices. Layer number 2, Data Link Layer, DLL. This layer is in charge for the node-to-node delivery of the message. It has to make sure that the data being transferred does not have errors from one node to another over the physical layer. When a packet appears in a network, it is the responsibility of the DLL to transfer it to the host using MAC address. There are two categories of the data link layer, namely media access control. The packet encountered from network layers is then divided into frames depending on the size frame of network interface card. DLL also encloses sender and receiver's MAC address in the header. Second one, logical link control, LLC. This layer controls flow control, frame synchronization, and error checking. The functions of the data link layer, DLL. Framing. A way is provided for this function for the sender to transfer a set of bits that are significant to the receiver. 2. Flow control. It brings together that amount of data that can be sent before receiving recognition. 3. Physical addressing. After the creation of frames, DLL adds physical addresses of the sender and/or receiver in the header on top of each frame. 4. Access control. When multiple devices share a single communication channel, MAC helps to regulate which devices has control over the channel at a given time. 5. Error control. It discovers and retransmits lost or damaged frames. 6. Bridge and switch are data link layer devices. Layer 3. Network layer. This layer works for the transference of data from one host to others situated in different networks. It takes care of packet routing, The IP address of the send and the receiver are placed in the header by network layer. The functions of the network layer. Logical addressing. It is responsible for the identification of each devices on internetworking uniquely. Routing. This is for the determination of which route is acceptable from source to the destination. Network layer is put into effect or action by networking devices such as routers. Layer 4. Transport layer. This is the provision of services to the application layer and taking of services from the network layer. The data in this layer are referred to as segments. It retransmits the data if an error has occurred. This is in control for the end-to-end delivery of the complete message. The functions of the transport layer, which is the heart of OSI model. Segmentation and reassembly. This accepts the message from the session layer and divides the message into smaller units. 2. Service point addressing. This is to make sure that the message being sent is delivered to the correct process. Therefore, services provided by the transport layer are connection-oriented service, a three-phase process which includes connection establishment, disconnection, and data transfer. 2. Connection-less service, a one-phase process, and data transfer is included. In this transmission, the receiver does not accept the receipt of a packet. It allows faster communication between devices. Layer number 5, session layer. This layer is in control for setting up of connection, authentication, maintenance of sessions, and ensures security. The functions of the session layer. Synchronization. This helps for the identification of errors so that the data is resynchronized properly and the ends of the message are not cut too early and loss of data is avoided. Number 2. Session establishment, termination, and maintenance. It shows the two processes to start, use, and end a connection. 3. Dialogue controller. This allows two systems to begin communication with each other in half duplex or full duplex. Layer 6. Presentation layer, also called the translation layer. The data from the application layer is taken from this layer and manipulated as per required format to transfer over the network. The functions of the presentation layer. Encryption or decryption. Data is translated into another code. Encryption data is ciphertext and decrypted data is used for encrypting and decrypting data. Translation, for example, ASCII to EDCDIC. Compression, the number of bits that need to be transmitted are reduced. Then we have the last layer that appears at the top layer, which is called the desktop layer. Layer number 7, which is application layer, also called desktop layer. This appears at the very top of the OSI reference model stack of layers, which is implemented by the network application. Data is produced by these applications, which will be transferred over the network. It also serves as a window for the application services, for example, Sky, browsers, WeChat, Messenger, etc. The functions of the application layer. Directory services. 2. Network virtual terminal. 3. File transfer access and management. 4. Mail services. Then we have our TCP or IP model. Now let's look at the purpose of the model. In this model, networking functions are separated into discrete layers. The specific function that will be performed by each layer must be transparent to the layer above it and the layer below it. Network models are used to explain and show how networks should work so that the network protocols and hardware can interact. There is a network model, which is OSI model, and then there is TCP/IP model. This model is the different way of looking at networking and the closest model of the internet. The four layers of the TCP/IP network model. First, application layer. User is provided with the interface to communication. It can be your email client, web browser, etc. This is where your web browser, email, or other client application runs. It can be other applications that goes on top of the TCP that uses a pair of network sockets and a pair of virtual network sockets. 2. Transport layer. The transportation for data segments across the internet layer. It is concerned with end-to-end communication. Under the transport layer falls two categories: use diagram protocol. Two computers that use internet protocol to communicate are provided with unreliable, connectionless transport of data between two sockets. Second, transmission control protocol. It is the opposite of use diagram protocol. The two computers that use internet protocol to communicate are provided with reliable and full connection for the transportation of data between two sockets. 3. Network interface. It is used for transmitting datagrams and acts as an interface between transmission links and hosts. It allows your computer to access the wireless or fiber optic network infrastructure and send data to other computers. This layer transmits data on the physical network when sending and transmits data to the internet layer when receiving. It elaborates what operation must be performed by links like serial link and classic Ethernet to meet the requirements of the connectionless internet layer. Last one, the internet layer. To transfer an independent packet into any network which travels to the destination. It includes ICMP, which is Internet Control Message Protocol, IP, Internet Protocol, and ARP, Address Resolution Protocol, as the layer standard packet format. It is concerned with network-to-network communication. This layer communicates with the transport layer when receiving and sending to the network access layer when transmitting. Then we have the Internet model. Let's look at the purpose of the Internet model. The purpose of this model was to allow computers to communicate over long-distance networks. The TCP/IP has become the foundation of the Internet because the TCP has to do with the verifying delivery of packets and the IP refers to the moving of data packets between nodes. And here's an interesting question. How does the Internet model differ from TCP/IP model? And here's our last question. How does the Internet model differ from TCP/IP model? And the answer is TCP/IP and OSI are the widely used networking models in communication. OSI is not a protocol but a reference model used for designing the system architecture and understanding it. TCP/IP is an equalized protocol used for every network with an internet included. OSI has 7 layers and TCP/IP has 4 layered model to describe how it works. OSI uses 3 layers, which is application, presentation, and session, to explain the functionality of upper layers, while the TCP/IP model uses just one layer, which is the application layer. All the layers in the OSI model are put together as a single layer in the TCP or IP model as application layer. The Internet model only utilizes some of the OSI model's 7 layers. OSI is an ideal model which is not used for communication, but the TCP or IP is used for starting a connection and communicating through the network. The OSI model supports connectionless and connection-oriented communication over the network layer, but in the transport layer, connection-oriented communication is almost not allowed, whereas the TCP or IP model allows only connectionless communication mode in the network layer but both modes in the transport layer. Here is a table of comparison between the two models. What is the definition, or what does OSI model and TCP or IP model expand to? OSI model expand to Open System Interconnect, and TCP or IP model expands to Transmission Control Protocol or Internet Protocol. The number of layers for OSI model are 7 layers, and for TCP or IP model are 4 layers. What is the meaning of OSI model? It is a theoretical model used for computing system. And what is the meaning for TCP or IP model? It is a client server used to transfer data over the internet. Who developed the OSI model? ISO, International Standard Organization, developed our OSI model, and TCP IP model was developed by the Department of Defense. Is the OSI model tangible? No. Is the TCP IP model tangible? Yes. What is the usage of the both models? The OSI model is never used, and the TCP or IP model is the mostly used one. And whether the obeys for the models. For OSI model, the obeys a vertical approach, and the obeys for TCP or IP model a horizontal approach. And in conclusion, we can conclude that the TCP IP model is reliable over the OSI model. TCP IP model is flexible, tangible, and used for end-to-end connection so as to transfer data over the internet. It also puts forward for consideration how data should be sent over the web. Therefore, the OSI model is just an abstract framework to interpret how applications communicate over a network. And that's the end of our presentation. Thank you for watching.